So I was given problem A1, and in this problem you're given two circles, circle C and circle D. For me, circle C was located about the origin with a radius of 5. And then you're also given circle D, and my point for that one, the center was 1 comma square root of 63, and that's this little circle up here. And I'm given the radius of 2. And then you're challenged to create the smallest circle possible that you can make that includes both of the circles inside of it while still being the smallest it can be. So knowing that, you know that that circle basically has to be touching both of the circles for it to be the smallest it can be. So you can sort of look at it as this radius can go up this way, this radius for that circle, and if you sort of add some lines in, you can make a full diameter for the big circle. And knowing this line, you can sort of find out the intersection points of where the big circle is going to touch the two smaller circles, and then from there you can find the radius of the big circle. So I first started off by finding what the diameter of circle E was equal to. And you know that it's going to pass through the origin, so I just use the point 0, 0 as the easiest way to find that. And then you know that the slope is the square root of 63 because this point up here is 1 comma square root of 63. So this is the equation for the diameter of the big circle, which I called circle E. And then you're going to sort of break down both of the two other circles to find the equations for them that you can then set equal to that equation. So the equation for my little circle D is going to be x minus 1 squared, that whole quantity squared, plus the quantity y minus square root of 63 squared equals 2 squared, because 2 is the radius. And then you want to get what y equals, so then you can set it equal. So if you just do some algebra, get y, my y was equal to the square root of the quantity 4 minus the quantity x minus 1 squared, and then plus the square root of 63. So now that I have y, I can set it equal to the equation of the diameter. So I did that. Be super careful with your math with all the positives and negatives. You get down to where you finally just have a quadratic equation. Mine factored, and I got the values -3/4 and 5/4 as my answer. But you can't include the negative one, because if you think about it, if you just look at your picture, I want that value to obviously be on this side of 1 to make the line work, so you want it to be greater than 1. So I can't have a negative value for my x, so you're just going to use 5/4. And then you're going to do the exact same thing for your circle C. This was my equation for it. I found it to be y equals the square root of 25 minus x squared. And then you're going to set that equal to the equation of the diameter as well. You're going to solve for that. And then this one for me, I got plus or minus 5/8. But again, you're not going to include the plus sign because this one, you want it to be on the other side of 0. You want it to be in the negatives of the x's. So you're just going to keep the -5/8. And then from there, you're going to plug those points back into this equation to find the y values of the points of intersection. So for circle C, my intersection point was 5 times the square root of 63 over 4. And then for my circle D, it was -5 square root of 63 over 8. So now that you have where the big circle touches the little circles, you're going to use the distance equation to be able to find what the whole diameter is of the circle. So you just plug in your points. Again, be super careful. You're going to simplify. When you take when you finally square both of them, you're going to get 2 of the same values. So I was able to pull out 225. So that's just going to leave a 1 plus 63 in there, which is 64. So the 64 on the bottom cancels out, leaving me with just the square root of 25, and that's equal to 15. But because the problem is asking for the radius of the big circle, you just need to divide it by 2. So my answer was 15 over 2.